This is section 9.7, factoring special products. We saw some special products before in earlier sections in the chapter, but they were in reverse order. In other words, they were given to us in factored form, and you had to multiply them out to find the product. Now you're going to be given the product, and you have to factor. So we're going to take a step backwards. The first special product is called the difference of two squares. And you've seen this equation before. A squared minus b squared equals the quantity of a plus b times the quantity a minus b. As I said, we worked on it reverse form before. But we're going to look at a polynomial here, y squared minus 16 equals, and then we're going to factor it. Now you can see that y squared minus 16 matches the pattern of a squared minus b squared. So we're going to break it down into its factors. That is, we're going to take the square root of a squared and we're going to add it to the square root of b squared. And then we're going to multiply by the quantity the square root of a minus the square root of b. And that's how we get y plus 4 times the quantity y minus 4. In the next case, you see 25m squared minus 36 equals, well, again, it fits the pattern of a squared minus b squared. So we're going to take the square root of the first, which is 5m, and we're going to add the square root of the second. Well, the square root of the second is 6. So we're going to have 5m plus 6 times the quantity 5m minus 6. Now you try the next one. X squared minus 49y squared. Does it meet the pattern? Does it match a squared minus b squared? Yes, it does, right? So what's the square root of the first? It's x. So we can fill the x in both parentheses. We know one has to be plus and one has to be minus to meet the pattern. And then you're going to take the square root of the second term. So take the square root of 49 and the square root of y squared. That is 7y. So we end up with x plus 7y and x minus 7y. Remember, when you're doing this, you have to remove the greatest common factors first. And that might reveal a difference of two squares that you didn't even know was there before. An example here is factoring this problem, which is 8 minus 18n squared. You look at it and see if it's the difference of two squares. It doesn't look obviously that it is right now. But if you remove the greatest common factor of 2, we get 2 times the quantity, 4 minus 9n squared. Well, you can see here in the parentheses, you now do have the difference of two squares. 4 is a square and 9n squared is a square. So let's break that out. Okay, break it down into its two factors. So it's going to be 2 times the quantity, the square root of the first, which is 2, minus the square root of the second, which is 3n, and then 2 plus the square root of the second, which is 3n. Okay, so sometimes you have to go through a couple different steps before you actually see the pattern, the difference of two squares. Here's some extra examples for you to work on. Why don't you take a second, you can stop this and work on these couple problems first. In the first one, you can see the square root of the first term is 8c, and the second term is 4, so it would be 8c plus 4, 8c minus 4. In the second, the square root of the first term is x, so that's simple. The square root of the second is 9y, so we'd have 8 plus 9y, 8 minus 9y. And in the third, a little more complicated, remove the greatest common factor first. So you're going to take 12 times the quantity, 1 minus 4m squared. Then you can break that down into the difference of two squares because 1 is a square and 4m squared is a square. So in this case, we're going to have equals 12 times the quantity, 1 minus 2m, and then 1 plus 2m. It's just a matter of seeing that it matches the pattern, and then it's not hard to factor at all. The other pattern we want to take a look at is the perfect square trinomial. Again, you've seen this pattern before, only in reverse. This pattern says that a squared plus 2ab plus b squared equals a plus b squared. And a squared minus 2ab plus b squared equals a minus b squared. An example of this would be n squared minus 12n plus 36. You can see it fits the pattern because if we take the square root of the first, it's n, and the square root of the last term, it's 6. And is the middle term 2 times the square root of the first times the second? Yes, it is. It's 2 times n times 6, which is 12n. So the answer factored would be n minus 6 squared. Here are some other examples of the perfect square trinomial. 9x squared minus 12x plus 4. Okay, doesn't meet the pattern. The first one is a square, it's 3x squared, and the last one is a square, 4 is 2 squared. Is the middle term 3x times 2 times 2? It is, so we can fill this in as 3x, and in this case, because there is a negative here, this becomes a minus here, in between. And then we take the square root of the 4, and that is 2. Okay? In the second one, the square root of the first term is 2s. In this case, we're adding, so we're going to put a plus here. And the square root of the second is t. Okay? Think about the next one. Doesn't meet the pattern. Is 6a 2 times the square root of the first term times the square root of the second? Is it 2 times a times 3? It is. So it meets the perfect square trinomial pattern. So this is going to be a plus 3 squared. You do the last one. 4n squared plus 20n plus 25. The square root of the first is 2n. We have a plus 20n, so we're going to have a plus in between these two terms. And the square root of the second is 25. So it should be 2n plus 5 squared. Sometimes you have to take more than one step to factor a perfect square trinomial. We've seen this before in previous sections. It's not obvious to see the pattern until you take out the greatest common factor. So in this case, you see negative 3y squared plus 36y minus 108. The first thing you do is take out the greatest common factor. And remember, whenever you have a negative before the first term, you have to remove that anyway. So let's factor out the negative 3. That's negative 3 times the quantity y squared minus 12y plus 36. Then look to see if it follows the pattern. Now if it doesn't, you can always factor it the way we have been factoring. But if it follows a pattern, it makes it really easy. In this case, it does, because the middle term is 2 times the square root of the first times the square root of the second. That's 2 times y times 6. So we can just say that it's negative 3 times the quantity y minus 6 squared. Here's some more perfect square trinomial factorization. Again, we have a negative 2 as a coefficient for the x squared. So you take negative 2x squared minus 16x minus 32 and remove the negative 2. Factor it out. That becomes negative 2 times the quantity x squared plus 8x plus 16. See if it fits the pattern. Is it a perfect square trinomial? What's your test? Take the square root of the first times the square root of the second times 2. Is that the middle term? Is that 8x? Yes, it is, right? So what are you going to fill in there? It's got to be plus the square root of the last term, which is 4. So it's a negative 2 times x plus 4 squared. Try the next two on your own. 2y squared minus 20y plus 50, and 3x squared plus 6xy plus 3y. Remember to take out the common factors first, and then it should be fairly simple. Sometimes you have fractions involved in polynomial equations. And I know we talked about factoring with fractions, and I told you we're going to be working with whole numbers. So what we need to do is eliminate the fractions. So when you see something like this first example, x squared plus 2/3 x plus 1/9, you need to eliminate those fractions. And I think the easiest way to do it here is to multiply by 9. If you do, it becomes 9x squared plus 6x plus 1. Does it fit a special pattern? See if it does. Is it a perfect square trinomial? Okay, take a look at it. The square root of the first term is 3x. The square root of the last term is 1. Is the middle term 2 times the square root of the first times the square root of the last? Yes, it is. So we can factor it. 3x plus 1 squared. To solve, you set each factor equal to 0. But look at this. Both factors are identical. You have 3x plus 1 times 3x plus 1. So you only actually have to solve it once, right? Okay, so we're going to solve 3x plus 1, and 3x equals negative 1, so x becomes negative 1/3. Okay, you only have one answer, only one solution here when you have a perfect square trinomial. Okay, let's take a look at this again. Another example, x squared minus 5x plus 25/4. Okay, get rid of the fractions. Multiply by 4. You get 4x squared minus 20x plus 25. Is it a perfect square trinomial? It is. Okay, it meets the criteria. Take the square root of the first, subtract the square root of the last, square it. But because you have two identical factors, you only have to solve this once. Only set one equal to 0. Your answer is 5/2. Okay? You see the result here is you only get one solution when you have a perfect square trinomial. Now we've only done 2 of these, but you could do hundreds, you could do thousands, your conclusion would be the same. Perfect square trinomials only have one solution because it's a result of a square of factors. Okay? Only one solution, and that's going to be really important when we get to this next chapter that's on parabolas. Okay, you'll figure out what that means. Let's take a look at a word problem quickly. This is the falling object example. Remember before we were doing jumping and throwing things, but now we're just dropping them, okay? And when you drop something, it has no initial velocity. So a window washer drops a sponge from 64 feet. We want to know after how many seconds does it hit the ground. We use our equation for vertical motion, h equals negative 16t squared plus vt plus f. In this problem, your S is 64, that's your initial height. The height at the end when it hits the ground is 0. Remember, the ground is always 0. And your initial velocity is 0 because it was dropped, it was not thrown. So your equation is negative 16t squared plus 0t plus 64. Then you have to factor it to solve it. Because you have a negative there, remove the negative, okay? Take out the negative 1. Some of you might be seeing that 16 there too. Fool around with it a little bit, okay? I took a negative 1 out, and I could see that it was a difference of 2 squares. The difference of 2 squares, that's what you want to get to, okay? So it's 4t plus 8, 4t minus 8. Solve it by setting both of them equal to 0, and you're going to get two answers. You're going to get t equals 2, that means 2 seconds, and t equals negative 2. But this is real life. You can't have negative time. We're not going back in time here. So here you can disregard the negative answer, and you only use the positive one. Your answer is 2 seconds. After 2 seconds, the sponge hits the ground.